Hello guys, welcome back to Educational Minds Hub. Today we're going to be discussing and looking at the three kinds of rocks. So, as I mentioned before, there are three kinds of rocks. The first one is called igneous. Then we have sedimentary and metamorphic. So igneous, sedimentary, and metamorphic. So let's look at igneous. Let's look at igneous first. So to think of how the igneous rocks are formed, let's imagine we have a volcano. This will challenge my art skills, but so that's the volcano's home. And then we have that. Actually, let me make it a bit different. So, what essentially happens is we have magma, right, inside of a volcano. So we have all of this magma. Side of the volcano, and then essentially when the volcano is ready to erupt, the magma will come out. So it'll come all out. It'll come out. And we have some over here too. And over some time, actually, there's going to be remnants of this magma, and this magma will eventually so let's say like all of the eruption is done, and this is the leftover magma. So yeah, let's say that's the leftover magma after the explosion. So, or not explosion, eruption. So essentially what's going to happen, this leftover magma, it's eventually going to cool, right? And that'll turn into rock. And that, my friends, it'll turn into igneous rock. So, let me draw in some igneous rock over here. So that magma is all gone, and it's replaced with the igneous rock. That was which was the cooled down magma. But that's not the only way for it to happen. Inside this volcano, if you go inside, you have essentially you have like this little chamber. Like a little chamber. So this is our chamber. And then essentially, some of the magma, it just goes in here. It goes into this chamber, and it stays there. Maybe it was lucky enough that, I don't know, maybe some rock like formed around it and kind of sealed it in, or maybe it was just not part of the explosion. It was lucky enough to stay there. So, and obviously this process will take longer because, you know, this is the earth, and it's going to provide lots of heat from the mantle and stuff. So it'll take more time as compared as this procedure over here. That would have taken way less time. It would have still been like lots of time, but like less time over here, and it would have taken more time due to this extra mantle heat. But eventually, that too will cool down and turn into igneous rock. Igneous rock. Once again, it'll take much longer. Much longer. Way longer. So now let's talk about sedimentary rock. So sedimentary rock. Let me get out Google. Sedimentary rock model. Images. Formation model. Alright, I like this one. Copy image. Paste. Alright. So, looking at the model and just basing a definition off the model, so what happens is these little pebbles, they fall into the ocean and kind of layer up on each other. And some material also falls in, maybe some plant and animal dies. So what you have is maybe you have your seawater up here. You have your sea. Let me label that as sea. And then maybe some of the rocks came, and then they start to pile up on each other and make a layer. So maybe this layer is called the rock layer. The rock. And then maybe there's some plant and animals that died. So maybe there's some fish here that died. There's a fish, or maybe there's a dead kelp here. All sorts of things. Doesn't just have to be sea life too. Maybe a dead twig from like a nearby plant was there. Twig. And so over time, what's going to happen is these stuff is going to layer on top of each other. It's going to layer on top of each other. It'll essentially layer on top of each other. So let me fill this in with black again. So then this all would eventually layer on top of each other. So, let me just do that. Whoops. Let me do that to note that they're separate layers. So, and as things stack up on each other, right? Like if you have some pancakes. So you have pancakes. And actually that's a good analogy that I just thought of. You have those pancakes that are stacking up on each other. Think of sedimentary rocks as that way. Like, you have your pancakes and then you have your syrup and all. So yeah, I mean, think about it that way. That way. But what it'll essentially do, it'll apply pressure, right? Pressure. Pressure. And the pressure will be greater the further down you go. And eventually, it'll be so compressed, it'll just compress in the rock. As this diagram says, it'll become so compressed that it'll turn into rock. And now, this isn't like an everyday, oh, today you have those sediments stacking up and then tomorrow you have rock. That's not how it works. It takes millions, lots and lots of time for this to happen. Like, a lot. And one good example of a sedimentary rock is limestone. Limestone. They're typically in caves. Mammoth Cave has a lot of limestone. Yeah. So that's essentially sedimentary rock. So metamorphic rock. Well, this word looks a bit crazy, but all you have to do, what you have to do, you have to look at this part. So morph, it's a word root. And all it is, it's the Greek word root for change. Oh, well. Change. You know, when you think of metamorphosis, you know, caterpillar, not the best caterpillar, but, you know, so you have your leaf here, and then you have, so you have your leaf, and then you have your little caterpillar just sitting there, and then it does its little cycle thing. I'll cover the life cycles of a caterpillar in another video, but it'll eventually turn into a butterfly, right? A butterfly. So, metamorphic essentially means change. So, metamorphic means change. And essentially, these rocks, they change. They change due to, so, change due to heat and pressure. So, change due to heat and pressure. Let's go to our old trusty friend Google. 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 In a sec. Let's clear that up as well. So, Google. I'm searching up, metamorphic rocks formation model. Oh, by the way, for the sedimentary rock, credit goes to, well, I don't know how to pronounce it, but this over here is the credit for that. Anyway, metamorphic rock formation model. So, Okay. Copy image. I'll use this. eSchool Today. That's the credit for this image. So essentially what happens is it takes those other two rocks that we talked about. Those other two rocks. So we had our good old friend the igneous. And we had our good old friend. The sedimentary rock. And what happens is these two types of rocks, due to heat and pressure, essentially what they do, they turn into metamorphic rocks. So heat from the magma would cause the igneous rock to change into metamorphic rock, and the sedimentary rock under pressure would cause it to change into metamorphic rock, or vice versa. Heat could cause the sedimentary rock to change into metamorphic rock, and pressure could cause igneous rocks to change into metamorphic rocks. Anyway, guys, thanks for watching this video. I hope you guys have a wonderful day. And have a safe, happy, beautiful, and great 2019.